Did you know that Wake Forest University has hundreds of active researchers that use high-performance computing every day? From physics and engineering to economics and biology, these researchers are comprised of undergraduate and graduate students, postdocs, and faculty from departments all around campus. High-performance computing, or HPC, is ingrained in their daily research. At Wake, the HPC facility where researchers conduct their work is known as the Distributed Environment for Academic Computing, or DEAC Cluster. In 2021 alone, over 650,000 tasks were submitted to run on the DEAC cluster, totaling 21 million core hours. While high-performance computing is widely used, learning how to use these resources can be challenging. So how did these researchers come to use the DEAC cluster for their HPC needs? When did they realize that HPC was necessary, and what impacts has it had on their research?
In research and education, questions bring answers. Answers create data, and data generates new questions. This cycle repeats over time and grows into more refined processes, generating more and more data. All too often, researchers find that the computer systems used to solve these initial problems become insufficient as the cycle progresses.
Our lab is focused on a few different areas of research. One of those is really looking at the malaria parasite itself. It's called Plasmodium, and we grow this parasite within human red blood cells in the laboratory. In my previous work, I have always used my own laptop to do the various types of data analysis that I've done. This worked out pretty well for a lot of the smaller scale experiments and the type of data that's generated from them. And I was even able to use it for some of the kind of limited scale work that I was doing with smaller metabolomics or transcriptomics data sets. The point where it really became clear that we would need to use the DEAC cluster was when a student joined the lab who was interested in doing RNA sequencing on time course studies of the Plasmodium parasite grown in different conditions. It's a very exciting project. We really want to get some great data out of it, but one thing that we really needed was some extra computing power and a better infrastructure to actually allow us to store that data and to analyze that data. And so in taking a course on genomics, he learned about the DEAC cluster. We were able to get in touch with the DEAC cluster and do some training, and so now we have that system to work with for our analyses going forward.
Migrating research from regular computer systems to the DEAC cluster can be an intimidating process. The HPC team meets regularly with faculty and students. They offer in-depth, hands-on user training and troubleshooting assistance. Users can also watch several tutorials and informational videos on the Wake HPC YouTube channel. The HPC team can also help users with their data management by transferring their data to the cluster's research file system that includes built-in backups, data loss prevention, and managed data access. Another service provided by the HPC team is code compilation and software management. The DEAC cluster already has over 200 software packages available for users, with various libraries, compilers, and software stacks to choose from. No matter what the question is, the HPC team encourages users to always reach out.
I'm looking forward to using the DEAC cluster for a variety of activities that our lab is engaged with. So one of those is just working with it for some of the analyses that I've already been doing. I'm just looking forward to using the cluster to sort of make those processes more efficient and just to kind of run some of those analyses there. And I'm also looking forward to the new opportunities that this will create. I'm excited about how we have this new project where we're going to be generating RNA sequencing data, and we really want to analyze this and understand something about how the parasites are transcribing different genes. And so I'm looking forward to graduate students in the lab really coming up on the DEAC cluster and learning and being able to run their own analyses on the cluster and come out with some really interesting results.
Supporting student learning is a top priority for the HPC team. Undergraduate and graduate students gain valuable experience using the DEAC Cluster as a tool to conduct their research, as well as a resource for courses they enroll in while at Wake Forest University. The HPC team has supported courses in the computer science and engineering departments, as well as the Master's in Business Analytics program through the School of Business, providing one-on-one support to students as they leverage the DEAC Cluster to complete their course assignments. In addition to supporting these courses, the HPC team also leads the instruction of the Intro to HPC's Special Topics course in the Computer Science department. The Intro to HPC course gives students the necessary background knowledge to efficiently use a high-performance computing cluster for research and covers a wide gamut of topics, including the architecture of supercomputing clusters and parallel processing and workflows. This course has no prerequisites and is considered a starting point to all students wanting to learn all about high-performance computing. Many students have enrolled in this course, gaining essential skills that have advanced many research projects across campus.
I've taken the course for 7 semesters, which I think says something about the quality of the class and the type of skills you learn. It really enables students to gain real-world skills that they would use in a computer science job that it's really hard to get in most classes. And I frankly think everyone should take this class because it's just so useful for them. I've personally gained an immense number of skills that I use every day in research from it. You learn how to compile software. You have to be able to figure out how to manage a high-performance computing environment. How do I manage a cluster? Through the past couple of years, we've also worked with cloud infrastructure. And so we've had to adapt and learn what the differences are, which really makes us need to know how hardware works on a deep level. This has been instrumental for me because it means when I need to go compile software on a new system, when I need to compile software on DEAC, I can actually work on that type of level. I can build my own software. I feel prepared to work in a research environment with these types of tasks because I know I've done it already with great mentors who've been helpful in helping me learn and pick up these types of skills.
Here at the Cordy Lab, I run RNA-seq on the Parasite Plasmodium falciparum. So at first I was hesitant reaching out to the HPC team because I have very little experience with computers and running databases. But actually speaking to them, I found them to be very approachable, and whatever type of questions I had, they gave me direct feedback and timely feedback. And I actually do feel more confident in the work I do and actually feel much better about the outlook of my project.
What? Oh, not my private again.
The high-performance computing resources provided by the DEAC Cluster, combined with the world-class support from the HPC team, are exactly what you need to accelerate your research.